Alrighty, so today we are talking about our introduction to factoring before we jump right into factoring tomorrow. And we're just going to do a little bit of review with some greatest common factor and factor pair stuff. So let's go ahead and get started. So this first question, it wants us to factor the greatest common factor from each expression. So if you remember way back in middle school, we talked about greatest common factor. That is the number or variable of the highest power or order that we can pull out from each of our terms in our expression. So if we look at our number 1, we have an x cubed minus 2x squared plus x. So we want to think about what we have in each of those terms. And in this one, so we have an x cubed, and in this one we have an x squared, and here we have just one x. So we want to pull out the highest power of x that is in each term. And in this case, all of our terms only have at least one x. So that means we want to take one x out of each term. So we're going to pull out an x, and if we take an x out of that first term, that means that we're going to be left with an x squared. And if we take an x out of our second term, our minus 2 is going to stay with us, and all we have left is that one x. And then if we take that x out of that third term, or we divide that third term by x, we would have x over x, which would mean just 1. So here we have x times x squared minus 2x plus 1. Now, if I wanted to double check my work, I could go ahead and do what we did yesterday, which is redistribute that x in front. We can redistribute our x to check our work. So if I redistributed that x, then I should go back and get that original expression that I got that was given to me, that x cubed minus 2x squared plus x. So that's number 1. So if we look at number 2, we see that all three of our terms have a coefficient in front of them, and that coefficient here is this 2, and this 4, and this 16. Well, that negative 16. Make sure we're being really careful with our signs here. So we have a 2, a 4, and a negative 16. So when we're talking greatest common factor, we want to think about the number that each of those can divide by, and we know that all three of those numbers are divisible by 2, so that means that we will be able to pull out a 2 from all three of those terms. So then once we're done looking at our coefficients, we want to go ahead and look at our variables. So for our variables, we have an x to the 4th, an x cubed, and an x squared. So remember, for that first one, we pulled out the highest power, and our highest power there of x was 1. But here, all three of our terms have a power of x squared. So we're going to take out a power of x squared. So it's like we're dividing our terms by 2x squared. So once we do that, we're going to go ahead and see what's left. So if I take a 2x squared out of my first term, that 2 is going to go away, and if I take an x squared out of x to the 4th, I'm only left with an x squared. Now if we look at my second term, if I divide that 4 by 2, I'm left with a 2, and if I divide an x cubed by an x squared that I took out, I'm left with an x. And for our last term, that negative 16x squared, if I divide that negative 16 by 2, I have a negative 8. And if I divide that x squared by the x squared that I took out, I don't have any x's left. I would just be left with 1. So we're just going to leave it as that 8. So I have 2x squared times x squared plus 2x minus 8. All right, now let's look at number 3. So for number 3, again, the first thing we're going to do is look at those coefficients, that 3 and that 9 right there. So that 3 and that 9, both of those are in fact divisible by 3, so we're going to take out a 3. Once we take out a 3, then we're going to look at our variables. So our variables, we have a y squared in the first one and a y in the second one. So our highest power, if you think about to the first one, the first question that we did, our highest power of y that we have is just a y, so we're going to pull out a y, and then we will write down what's left. So if I take a 3y out of 3y squared, all I'm left with is a y, and if I take a 3y out of negative 9y, so if I divide that negative 9 by 3, then I have negative 3, and if I divide the y by y, I don't have any y's left, so that is what I'm left with. Okay, so now let's look at number 4. Again, the first thing we want to do is check those coefficients. So I have 3, a 6, and a negative 9, and I want to find the greatest common factor of 3, 6, and negative 9. Once again, that greatest common factor is in fact a 3. Alrighty, and then I want to look at my variables. Now this question has two different variables in two of our terms. So that first one, we have an x in our first term, an x in our second term, and an x in our third term, which means that we can take an x out of all three terms. Now we want to look at that y variable. So our first term has a y squared, our second term has a y, but our third term does not have a y. So since there is no y in our third term, it can't be factored out. It can't be factored out. Okay, so don't try to pull a y out of those first two terms because there isn't one left in that third term to pull out. Remember, whatever we're taking out, whatever we are factoring out of these expressions has to appear in all of our terms. So if all we can factor out is that 3x, then we're going to write down what's left. So if I divide that 3x squared, 3xy squared, by 3x, then we're just left with y squared. And then we have that 6xy. So if we have that 6xy and we divide it by 3x, or we take a 3x out, that 6 divided by 3 is 2, and x divided by x is 1, so we don't write it, and then we're left with that y. And then our negative 9 divided by 3, we're left with a negative 3, and x divided by x is 1, so we're just going to leave it like that. So our answer here is 3x times y squared plus 2y minus 3. Okay, let's look at number 5. So for number 5, I have negative 5x to the 5th minus 15x cubed minus 45x. So once again, the very first thing I want to do is take a look at my coefficients. In my first coefficient, I've got a negative 5. My second one's a negative 15. And my third one is a negative 45. So I want to go ahead and see what my greatest common factor of my negative 5, my negative 15, and my negative 45 is. And this is the leading coefficient of that first term, which is negative 5. So I'm going to pull a negative 5 out of all of my terms. Then I want to look at my variables. So I have got a x to the 5th, an x to the 3rd, and an x. So the highest power of x that is in all three of those terms is only 1x because this last term only has 1. Remember, we have to look for that lowest highest power almost. So all we can pull out here is that 1x, and then I'm left with an x to the 4th in this first term because I took out a negative 5x. So if we divide that negative 5x to the 5th by negative 5x, all I'm left with is an x to the 4th. And then if I have negative 15 divided by my negative 5 that I took out, I have a positive 3. And the x cubed divided by x leaves me with an x squared. And then that third term, if I divide negative 45 by negative 5, I have a positive 9. And if I divide the x by x, I'm again left with 1. So we're just going to make the x go away. Alrighty, let's move on to number 6. Once again, we look at our coefficients first. I have a 7, a negative 21, and a negative 49 are my leading coefficients to each of my terms. So I want to find my greatest common factor. In this case, that factor is 7. So I'm going to take a 7 out of all of my terms. Next, I want to look at my variables. So I have a b cubed, a b squared, and a b. And again, my smallest power that I have of b is just 1, so I'm going to take out a b. I have 7b. So now I need to write what's left over. So if I divide 7b cubed by 7b, I'm left with b squared. Negative 21 divided by 7 is negative 3. I take 1b out of the b squared, I'm left with just 1b. And then negative 49 divided by 7 is negative 7. B divided by b is 1, so we just leave it b. Okay. So, number 7, I want you guys to maybe try to pause the video here and try to do this one on your own, see what you can pull out. And I'm going to go ahead and work through it without talking about it and see if you can follow along and understand what I am doing as I work through it. Alrighty, so if we look at this one, as you can see in purple, I've highlighted our 2's that are our leading coefficients for each of my terms. So I have those 2's, I pulled that 2 out, and then I highlighted in orange my x's. So in that first term I have an x squared, in the second term I also have an x squared, but in the third term I only have one x. So I can only pull out an x and not an x squared since that third term only has the one x. And then I went ahead and read and highlighted my y's. So the first term I have a y squared, in the second term I only have one y, and in the third term I have a y squared. So similarly to the x's, I can only pull out one since that middle term only has one y. And then once I've factored out a 2xy, I have to write what's left. So when I take a 2xy out of my first term, I'm left with x times y. And then when I take the 2xy out of my second term, or I divide that term by 2xy, the 2 goes away, the y goes away, and all I'm left with is 1x, or just an x. And similarly for that last term, if I take a 2xy out of that last term, the 2 divides itself, the x divides itself, and the y divides itself. So let me kind of write that out, that division that we're talking about. So if I have 2xy squared divided by 2xy, we know that that y squared, we can write that as 2xy times y over 2xy. And then once we have this, we can cancel top and bottom. Maybe this visual will make a little bit more sense. So some of you that might be struggling a little bit, as you can see, the only thing that we're left with is this y, and that's why that's going to go here. So if at the beginning, doing this division step when you figure out what you're pulling out might be helpful, but hopefully we're getting up to speed of recognizing when we pull something out, what's left over. So when you're doing your practice, if I see some of this, that's totally okay, but let's try our best to like move forward with just recognizing how many powers we're gonna have left over. Okay, so I'm gonna do the same thing for number 8. Maybe try to pause the video and work this one out on your own and then check your answer with mine. So I'm gonna go ahead and do 8 and 9 together at the same time, and then y'all can just check your work. Alrighty, so if we talk about these ones, let's look back at number 8. So number 8, I looked again at my coefficients. First, I see I have a 9, a 27, and a 54. I know all 3 of those are divisible by 9, so I take out a 9. Then I look at my variables. So I have an x raised to the 7th, an x raised to the 5th, and an x raised to the 4th. So my smallest power, or the highest power that I can take out, is that x to the 4th. So I take out that x to the 4th, and then I have to write what's left over when I divide each of my terms by 9x to the 4th. So when I divide that first time by that 9x to the 4th, all I'm left with is that x cubed, because remember, when we multiply exponents, when we multiply 2 things to an exponent, we're actually adding the exponent, or when we divide, it's subtraction. So if you went and redistributed that, you get back to that 9x to the 7th. And then if we look at that middle term, I have 27x to the 5th. If I divide that by 9x to the 4th, I'm left with my 3x, and the 54x to the 4th divided by 9x to the 4th is the 6, because 54 divided by 9 is 6, and x to the 4th divided by x to the 4th is just 1. Okay? So if we look at number 9, again, the first thing I do is I look at those coefficients, those numbers in front of my variables. So I have a 3, an 18, and a 6. I know that all 3 of those numbers are divisible by 3, so I take out a 3. And then I'm going to look at my variables that I have attached to those coefficients. In my first term, I have an x cubed and a y squared. In my second term, I have an x and a y. And in my third term, I don't have any variables, which means that I can't pull any variables out of this expression to make it any more simplified, since it's not in that last term. So once I take a 3 out of all 3 of those numbers, I'm left with that x cubed times y squared plus 6xy plus 2. So that's all for greatest common factor. You guys will have some practice just like this on your homework for tonight, okay? So let's talk factor pairs. So factor pairs are 2 numbers that multiply together to get another number. Again, this is really basic stuff that you guys learned a long time ago, but we're just going to review because it's going to make our factoring unit go much easier. So if I'm thinking about the number 12, we want to think about the two numbers that would multiply together to get 12. And you should always, for any integer that you're given, be able to think of at least one pair, and that pair is always 1 times the number itself. So we know that 1 times 12 is equal to 12. Then the first thing I like to do is think about, okay, is this number even or odd? And if the number is even, then we know that it is divisible by 2. And we know 12 is even, so 12 is divisible by 2. 12 divided by 2 is 6. So my next factor pair is 2 and 6. And then you should know, it's kind of going through and thinking, okay, what number also divides 12? Well, I know 3 divides 12, because if you add the 2 numbers that make up 12 together, 1 and 2, 3 is divisible by 3, and then you know that 3 is divisible by 12. Or 12 is divisible by 3, excuse me. So 12 divided by 3 is 4, so those are our factor pairs. Now, when we get into factoring, we'll need to find factor pairs of positive and negative numbers. And so we know that 2 positive numbers multiply to be a positive number, and also 2 negative numbers multiply to be a positive number. So all of these pairs could be positive or negative of each of these pairs. So if I had a -1 and a -12, that would give me multiplied together a 12. So make sure if you have a positive number, you can have all positive or all negative for your factor pairs. All right, number 2, again, that first one that you come up with, the first pair should always be really easy. But if you look at number 2, we have a -16. So 2 numbers that multiply to it be a negative, one will have to be negative and one will have to be positive. So there's 2 pairs that you can come up with automatically. That first one is -1 and 16, and the second one is 1 and -16. So they always have 2. If it's negative, there's 2 that you should be able to come up with super quickly to find your factor pairs. The next one that you should be able to think of, because -16 is a even number, is 2. You know -16 is divisible by 2, so you have -2 and 8, and you also have 2 and -8. And then you should know that -16 is a perfect square. It's divisible by 4, so you have -4 and 4. And since that one's already 4, it doesn't matter which one of those is positive and which is negative. All right, let's look at 3. So number 3, we have 59. 59 is a prime number. This is a prime number. And if we have a prime number, that means that the only factor pairs of this number are 1 in itself. 1 in itself are the only factor pairs for this number. Okay, so I want you guys to go ahead. You guys try to do -32 and 70 and -64 on your own while I write them out right now. Okay, so those are your factor pairs for -32. So 70, we could have these are positive or negative. Since it's a positive number, all positive or all negative. And for -64, So here are my factor pairs for negative 64. Alrighty, so if you look on the back of this page, it's just a reminder that our perfect squares quiz will be coming up on Friday. So if you want to take the space to write down all of your perfect squares from 1 to 12, remember that's like 1 squared is 1, 2 squared is 4, 3 squared is 9, etc., 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 up to 12 squared is 144. Go ahead and you can do that here. Like I said, there will be a quiz on Friday. We will be taking it in pen. Yes, I know that there is a pep rally on Friday. We're still going to take a quiz because it won't take any longer than 5 minutes to do. You will need to know how to write them as if I give it to you like 1 squared, and you can tell me that that is 1. Or if I give you like 36, you need to be able to write that as 6 squared for me. It'll be both ways. I hope you guys are having a fantastic day and being very wonderful for the sub. If I get a good report for both classes, maybe Miss Layden will bring a special treat for you guys later this week. Alrighty. Y'all have a practice to work on for the remainder of class. Please be sweet for the sub. Thank you.